Okay, hey Miss Stavna. So this is my partner and I's model that represents muscle contraction as well as how muscle contraction relates to rigor mortis. So first, let me orientate you with our model. So the brown tube here is the myosin filament, and on the myosin filament are these little projections, I guess you could say, that are called myosin heads. So that's it for the brown part. And then on this part, we have these red dots, which represent hydropenin, which is what calcium ions attach to, but that will be discussed later. And then the hydropenin is attached to trypomyosin, which is represented by the yellow that is swirled around the orange. And then the orange represents the actin filament. So I think that's everything to show you in our model. Sorry, I'm out of breath because I've done this a few times. Okay, so to start off, this isn't represented by our model, but action potential travels down the nerve and encounters the axon terminal. And the axon terminal then releases acetylcholine, which is a neurotransmitter transmitter that initiates calcium ions to be released into the muscle. And as I said before, these calcium ions attach to these red dots that represent the troponin. Then these myosin heads, or in these myosin heads, I should say, there are ATPase enzymes that hydrolyze ATP and produce ADP phosphate group, I should say. And when the ADP is created, these myosin heads here will then attach to the actin filament like that. So once the phosphate is released, it will cause something called a power stroke, which basically means that the myosin filament will move along the actin filament. So let me show that there. So that's essentially what a power stroke would look like. And this power stroke is what, or that's the muscle contraction. That's essentially what muscle contraction is. And then the ATP will come in and detach the myosin heads from the actin filament, which allows the muscle to relax. Which, means that it's no longer contracted, I should say. So now for rigor mortis, where does that come in? So rigor mortis is the stiffening of the muscles after death. So this happens in animals and humans when they die. So when animals and people die, their muscles stiffen and they are no longer taking in oxygen. They're no longer breathing. So when this happens, in order to produce ATP, there needs to be oxygen. And so if ATP is no longer being created by the body that we are talking about, whether it's a human or a person, the myosin heads are never detached from the actin filament, so they stay like this, attached. And this causes an issue because the muscle is not relaxed. It stays, contracted like this. And this is why rigor mortis is stiff, because the muscles are not relaxed. They're contracted, they're stiff. And so this is why that occurs, is because the ATP is no longer being produced, which is what allows for the myosin heads to detach from the actin filament to allow relaxation of the muscle. So that's what rigor mortis is. That's why the muscles get stiff is because they are stuck like that, not like this. So that's it, Dogda. There's one last look at our model. Thank you for letting me explain this. Bye.